I do have what I think is some, and I would hope, rather useful content that builds on what we saw earlier this morning with Michael's keynote, the demo, the briefing from the Red Monk analyst. But because we're more on the cloud computing basics here, I want to start on this idea, okay, what is cloud? Not a lot of time there, since at this point most of us know what we're talking about, but it's just context. But my thesis throughout is you can use cloud computing, and when you do, you probably want to take advantage of a cloud management platform, hence RightScale. We can make it more generalized, say use a cloud management platform, which is, well, I'll make my case of you want to use that, and then I'll make specific pointers about what do we do in that regard, why RightScale there. And we have something of a humorous angle here, though it's rather serious. Michael, our CEO, said, why don't you come up with the 5 commandments of the cloud? And we did a little of a play of words on the Decalogue, but it's actually rather serious, where we're trying to make it fun, and it should make it more interesting that way, I would hope. So cloud, there's lots of definitions. The one I like quite a bit is it's just a metaphor for complexity you don't need to manage. Simple as that. If I'm not managing something, it means I don't have to worry about what's happening in that cloud or behind the scenes. And in fact, I've been at this quite a while. I used to work for a telephone company, and one of the things we did was connect for our customers disparate offices around the country. And back then, this is even before the internet, there's a thing called fast packet networks, frame relay, and asynchronous transfer mode. And we would actually give them a diagram with a cloud in it. So I sanitized that to make it a little bit cleaner. That could be the San Francisco, LA, Houston, and Chicago office. So what this would mean is that there was a whole bunch of complexity we were managing for the customers to actually have a connection for their computer network between those offices, but they didn't need to worry about what was happening in there because we took care of that. We were just handing off to them at the edge of the cloud. We call it the point of demarcation. That's where we hand off a circuit to you, and these used to have IP addresses in them, and then you take it from there and it works. If you think a little bit of the evolution of cloud computing when we talk about infrastructure as a service, and this is sort of on the geekier side, we just move that point of demarcation to now not just include the network, but also the servers themselves. Just sort of abstracting at that complexity again. Complexity you need to manage. And this goes back quite a while. That's why I'm referring to the 60s, where you had mainframes and just simple terminals where people could use it. So the idea itself is not new. It's just this evolution of what you can do with technologies. And another useful way to look at it is that it's an application-centric operations model, as opposed to a network-centric or hardware-centric or data center operations-centric model. We spend so much time worrying about data centers, and now, as a company, you worry about your application. It's an application-centric delivery model because you don't need to worry about the layers below that. And there's a few interlocking phenomena that are all driving this huge adoption to cloud. And we lead with cut costs, but that actually comes in many different ways. If you just take a straight comparison between buying a server and renting it from an infrastructure service provider, well, there's lots of ways to slice that. We had Trader Media presenting 6 months ago in the New York version of this conference, and I think his title was CTO or Director of IT, told us that because he was using cloud computing and he was able to deploy a new website for Trader Media. I think he said 3 to 4 months faster than they had expected, they realized an additional $1 million in revenue. So cut cost doesn't mean always necessarily exactly I paid for this and I paid for that. It means you're weaving into this whole idea of improving agility. What is it worth to your business to be able to do things faster, to pivot, to change the plans and not have to pay a huge penalty tax for lots and lots of time, which also ties into this idea of scaling reliability. It used to be that frankly, you had to take some scary guesses sometimes when you were buying infrastructure and putting it into place because you had no idea how much consumption your systems were going to take. This goes back to the very early days of Zynga when they had their own data center. By the way, Zynga makes Facebook games, and now they're fairly famous for just having tens of millions of people that play every month and hundreds of millions of people that play every week. But this really applies to lots and lots of things. You have any kind of application, whether public-facing or internal-facing, frankly, you got to take a guess. How much usage is it going to take? And that'll drive through to how much equipment you need to put in place. And it's almost impossible to guess that right. Anybody that's worked on this will tell you, you'll be above or below whatever you guess, but you never get it right. But those were big bets before. This idea of cloud computing also in a major way alleviates and ameliorates those kind of situations where now you had to wait 3 months to get the new equipment and be able to expand and all that. And the one that ties into this idea of why a cloud management platform the most strongly is leveraging best practices. This idea that you're building things that have the best approach to architect things woven into them, baked into them, so that not every single person in the company needs to know exactly how to build it and they can get the benefit of it. So Michael talked about this whole idea of software as a service and platform as a service and infrastructure as a service. I will not go into that again, but just to highlight this idea that true infrastructure as a service, clouds are API driven. I said that earlier in the morning. It really is a powerful statement because that means they're tools. It's not just a user interface where you can log in and do whatever you can with a mouse and clicking here and there. It means it's a cog in a bigger machine where you can build other machines on top of it, as you saw with that very simple self-service portal that we were talking about. That's a big part of those capabilities. Now this is a diagram I'm borrowing from my friend, from Stephen Wardley. He's no longer with Canonical. I don't know if you can see this in very small font. And he's talking about here the adoption rate. So adoption on the y-axis over time on the x-axis of new technologies and where we are with cloud computing and how that happens over time. This is really changing industries in several ways. If you think about the innovation, it's not just technological, it's not just, for example, Amazon Web Services that has led the way here, taking this idea of virtualization and service-oriented architectures and really taking it that much far forward. The innovation also is in the business models. They took what was data center sales, which was expensive sales, enterprise salesperson visiting a customer, making a big commission, taking many months to buy, having to write a big check, big purchase order. And they turned it into a self-service model that's very related to e-commerce, maybe because that's where they were coming from. They said, here's our standard pricing. It's public, it's transparent for everybody. You want to buy this, you come here, this is the published rates. Sign up, give us your credit card number, and you can buy this and you can deploy it. So it's a few phases of the innovation that has really brought this different changes in the different models. Now, what we're seeing here is we're getting closer and closer to this idea that it's more ubiquitous. You know, there's that quote, the future is here, it's just not evenly distributed. And I forgot the name of the sci-fi writer that did that. He wrote Cyberpunk, if somebody can help me with the name of the author to properly attribute that. Gibson, thank you very much. What we're seeing, because we're really at the tip of the spear in this tectonic change in how companies buy and consume IT resources, is that the more innovative companies are able to, because they're maybe perhaps a little bit more of a risk taker, are able to take more advantage of these new tools and, without exaggerating, significantly impact their business in a positive way. And perhaps open up a gap with their competition that are more laggards when it comes to change. There's more seats over here if you want to grab one. And let me give you simple example to go again with Zynga and Facebook games that I was mentioning before. Well, let's generalize it so it's not a particular company name. I believe they're in their quiet period before they go on their IPO. You're a company deploying a Facebook game. Now you need to tie up a lot of resources into capital for equipment to have in a data center to run the game. Not only that, but you also need to have sizable teams of people to run and maintain those machines. And it takes you weeks and months to be able to deploy those things versus a smaller company that can be nimble, that can do this a lot faster. Again, this whole idea of agility. That translates into a business advantage that we are seeing. Notice, like it often happens, innovation comes from without, not from within. It wasn't an existing gaming company in this case that came up with these games that all of a sudden tens of millions of people started playing on a daily basis. It was somebody that wasn't tied down to the old way of doing things that said, let's take advantage of the new tools in a maximum way, to the largest extent we can. So, I mean, I'm painting a very rosy picture here. So what's the problem? Isn't this just fantastic in every way that you can think of? Well, to quote another phrase from earlier this morning, accidental tourists in the cloud. The fact that you can log into a console or make an API call and send up a server somewhere and you're paying by the hour doesn't mean you achieve unqualified success. If you think about it, those are merely building blocks. Think of it as compute primitives, server or compute power, storage, IP networks that tie them together. This whole concept that we've been expounding of cloud management platforms is taking those building blocks and turn them into actual useful systems and making it a lot faster and a lot easier to be able to deploy those. The idea that I was talking a moment ago about best practices built in so that you have security and more reliability, and perhaps even most of all, and you heard us driving this point quite a bit earlier today, this whole idea of not getting locked into a single provider. If you design an application that's deeply woven into the way that a particular infrastructure as a service provider works, now you can never port it anywhere else without having to essentially rewrite a whole big chunk of that. So we came up with the 5 commandments of the cloud. I need to read those, I don't have them memorized. And I mean, we're trying to be a little bit humorous, but actually the message, I think, is spot on. So, thou shalt automate. Here's a diagram from IDC showing on the blue dotted line the number of servers deployed by large enterprises over time. And what I want to point out here is this blue bar. Not only is it the biggest component, maybe not in the earlier stages, but in later years, but it's also the fastest growing. So people talk about TCO, total cost of ownership. Yeah, it's true. It's not how much that particular piece of hardware costs or how much it costs to develop a particular piece of software, although software is not what I'm showing here. It's how much it costs to maintain it and to run it. Notice that's where most of the cost goes. And I'm driving this back to what you want a cloud management platform, by the way, to help with that part of it. So this is over time. This is just a snapshot of what it looks like on any given day. Most of the cost that you can see outlined here in the red is managing those deployments and then trouble and issues related to those. And this is data from IBM. The GFS is a division of IBM that does consulting and manages environments. So what we're seeing from companies that take extreme advantage of cloud computing and cloud management platforms is this tremendous ratios of server to sysadmins. I was talking to, I didn't ask him permission, so let me not say the company, particular link sharing website. VP of engineering has one part-time helper, and between the two of them, they manage an environment that, depending on the time of day, because it changes with the traffic, is anywhere from 350 servers to 100 servers, depending on the time of day. One person with a part-time helper. This would have been a team of people before. And the best part of the message for me was that he says, I'm never running around putting out fires, because we've designed it, and by the way, they've been very, very clever. We designed it to be self-healing, to be able to run. It's not that problems never happen, is that because now you quite literally have disposable hardware at your fingertips, you can have environments that are more or less self-healing. A machine breaks down, another one stands up to take its place. And when you consider that most of the cost is here, that's what we're talking about being able to reduce. Now let me give you a couple of examples. Michael talked about this when I was doing the demo, and at least now we can put some pretty graphics to them as well. So American Girl, this is a division of Mattel, had already put in the mail, it was either 3 or 4 million catalogs, and they were featuring the URL for American Girl University and come to the website. They were already in the mail when they started testing the deployment that was not in the cloud, by the way, and it turns out that we're getting 10% of the concurrent users they thought they could get per server. And they said, uh-oh. I don't know how much money it was, but there were millions of dollars worth of marketing spend at stake, and I don't even know how to calculate brand equity type of negative impact you would have if you put out this campaign and it's not running. Not unfamiliar to us to get a call like this, and when it's a big company, it will actually go to the CEO, all the way to the CEO pretty quickly. And we went into we're really a software company, not a consulting company. When it's something big like this, we'll say, sure, we'll help you, because they said, no matter how much it costs. Let's get this thing running. And really, it was a marathon session over a weekend. Man, myself here, the heroes are the engineers working on it. And they had this environment running again, or fully transposed to the cloud, or the key parts anyway, so that as that traffic came in, and it was a lot more than they expected, they were able to cope with the massive traffic. And there's really quite a few examples of this. We only get permission on some of them to speak about it. Michael talked about how everybody loves free chocolate. In the case of M&M Mars, they didn't deploy this to the cloud right away. They had a set of servers in their internal network somewhere, and they said, come to our website, register, we'll send you free chocolate. Who doesn't love that offer, right? And the servers were in their data center somewhere, part of the corporate network. Well, they gave themselves a denial of service attack, a DDoS, distributed denial of service attack. So many people were coming from so many different places to hit this website that not only did the website not work, the corporate network didn't work that day, and maybe for longer than a day. So big impact to the business. This is the one that we were talking about earlier, where this was a little simpler actually. I think they called on a Monday or a Tuesday. By Wednesday, I think by Thursday, there was a specific statement of work agreed upon exactly what was going to be. They had it running by Saturday because this thing, they already bought either newspaper ads or radio ads. It went up again, and first day, that was a Sunday, 35 million people visited the website and it ran. I'm really making the point of the automation. You just architect things for scalability, not for the particular number of visitors, because you don't know exactly how much that is going to be. So thou shalt automate, I meant to say automate for scalability and for automating any human processes that you can move out of the way, abstract out. Thou shalt go forth and reproduce cloud server environments. So why reinvent the wheel over and over and over? Here's a screenshot of the MultiCloud marketplace. We started building a lot of server templates ourselves. Everything and anything that's open source, because we didn't need to ask anybody permission. So Apache and MySQL and things like Ruby and so forth. And I'm not sure how long ago now, maybe 2 years ago, I started reaching out to commercial software companies. And now we have a pretty vibrant marketplace of the open source things that we've been creating and supporting for quite a while. But increasingly, I'm proud to say, lots and lots of commercial software from small, medium, and some very large companies like IBM that make their software available there. Why spend all this time reinventing things that other companies can create? And a big part of RightScale really, and I don't want to get too technical, but I do want to share this, is this idea of server templates that writes at the core of RightScale. And I want to draw a distinction between that and virtual machines, which are very popular. In a virtual machine, which has existed for a long time, you stand up a virtual server, you spend some time installing, configuring things, building it just the way you want it, and now you can clone it as many times as you want. And that's it's very useful, an identical clone in every way. But 4 years ago when we started doing this, we realized, yeah, that's useful, but it turns out you don't want identical clones. You wanted something to be pretty close to what it was before, but not identical in every single way. So Torsten von Eichen, our CTO, came up with this concept of server templates, which is also a virtual machine, but what we do is, instead of putting everything in it, we just put the operating system in it. Just CentOS, or just Ubuntu, just Windows, and really just enough OS to boot. That's it, just enough for the machine to become useful. And once the machine boots, we start running scripts, write scripts that you heard about before, that install and configure things. So think of a server template as the combination of that virtual machine that only has the operating system and the scripts that will build it and configure it to be what it needs to be. It's really like DNA. It's not a photocopy of the last thing, it's a DNA recipe that will build the machine over and over, but over and over, slightly different depending on what you need to do. So that's what makes it possible to take it from a particular cloud, say Amazon, and then move it to Rackspace if it's using a different type of storage, to have a single server template that can be either the master database or the slave database, because you can pass it configuration parameters. It also means that there's fewer things to maintain. We have a customer that has 12,000 servers, but only has one CentOS 5.4 image to maintain. He's got HA proxy and Memcache and MySQL and Apache, lots of different server templates, but only one set of security patches to maintain and to worry about. Huge part of the benefit comes out of this kind of technology. And if you're talking to other people in your company or people in the industry, I know this might be harder to explain if you don't live it and breathe it every day like we do. Here's a simple analogy. A virtual machine is like a CD, copy it as many times as you want, but you can't change a single bit. It needs to be identical. A server template is more like a playlist in your iPhone. Change the order of the songs, add songs, delete songs, a lot more customizable, and that's where a lot of the flexibility and the power comes from. And it's useful in different ways. When we have developers that can have an all-in-one machine that in the same machine, say, has Apache and PHP and MySQL, so that would be a server template, and it boots up. It will literally have a script that installs MySQL, installs Apache, installs PHP, and I can use that as my dev box. That's useful when I'm just developing a particular program. Later on, if I actually want to start testing it in a staging environment, I can just move the scripts, they're modular, to different server templates, and I can turn that into a multi-tier environment for testing, and I can take it to the logical conclusion of moving that into an actual production environment. And that's what Michael was referring to earlier today when he talked about how many different server templates there are that our customers are making for their own use, and almost 1 million different write scripts that are quite reusable. You can move them to different machines, and people do. Not just single machines, but complete environments. This is not quite your classic 3-tier architecture, because it also has a caching tier. But the point I want to make is, and that shall go forth and reproduce server templates and server environments, is you want to build this thing over and over and over, or you want to put the effort it takes to build it properly once and make it possible for different groups in your company to access it, or for a software vendor, like we've done with Zen, PHP, and RightScale together, put our combined expertise into something like this, and then make it available for people to use without them having to know everything we know about what it takes to have load balancing and database replication and session clustering and all that. That shall control and have visibility of cloud resources. So in the RightScale management dashboard, and this is the more prosaic, maybe call it boring part, but it turns out to be the most useful and probably important. Lots of cloud resources going on, lots of users in your company having access to those. Michael talked about how we've seen a huge expansion of how many logons per RightScale customer into each account. So what are they doing and what's happening? So let me jump into that since I went ahead. Being able to give different people different levels of access. Does every single user supposed to have access to every single server and machine that you have across the entire enterprise? Being able to control that, being able to separate things about saying, well, the QA team should have, or maybe I just made a new staging environment that I'm outsourcing to a QA team outside the company. Let's give them access to that, and only that. Being able to control those kind of things. And on top of that, having an audit trail about who logged in where, what they changed, what parameters were modified. Things like that are incredibly useful. I mean, I'll tell you, I was going to say anecdotally, but really it happens all the time. People call and say, did you guys break my MySQL database, or what happened to my machine? It broke for no reason. And somebody on the RightScale customer support will say, so you give us permission to log into your account and see what's going on? And they'll say, yeah, sure. And they go, who is Jay Johnson that logged in about half an hour ago? And they go, oh, he logged in half an hour ago? Okay, let me go talk to him, see what happened. And then we can sort of trace what happened. The amount of time savings there is hard to exaggerate. Jumping back up to this idea of logs. In this world of, as I was saying, literally disposable hardware, the machines come and go. So what happens to the server logs in console feedback? So that's what you're seeing on the screen as you're configuring a server. That disappears too when you shut down a machine. So we learned a long time ago to save those and persist those, so that if you've been having all these servers scaling up and scaling down over the weekend, where maybe you went away to your cabin in the woods or something, you come back and you say, what happened to my whole environment? People hadn't thought about this before. Well, we have the ability to actually reconstruct everything that was taking place, so you can see, all right, this is for good or for bad. Maybe you're troubleshooting something, maybe you just wanted to understand what was happening in the system. And the one that people with business line responsibilities like the most is this idea that you can group servers into deployments. It's just a logical grouping of machines. This particular application, let me put all the servers together into what we call a deployment. A lot better than looking at servers in alphabetical order, especially by cryptic server IDs. That's really confusing. Here, I can put them all together and see that this is, game XYZ. And then you can track them by cost, right? I used to work at a data center, and you walked in and you couldn't understand what the machines did, just lots of servers with lots of machines and cabling everywhere, and much less figure out what costs what. You would just get a bill from the data center. You owe 100,000 this month or whatever it might be. It really is a massive advantage for companies that want to do area-based costing to say, this is how much development environments cost versus production versus staging and dev, or if we have a software as a service company, to be able to have 1,000 customers running, this is how much the infrastructure costs. That kind of visibility. And let me be very brief on this one. Super useful for people that do and have to manage security. You can take a snapshot of exactly, from a security standpoint, where the access is, what ports are open and closed, and exactly how the servers are configured. And then you can take that snapshot again a few weeks or a few months hence, compare them to see what's changing. Again, benefits of a cloud management platform that are very hard to realize when you're trying to build this on your own. In many ways, the question is, what business are you in? Are you in the business of making cloud computing tools, or are you in the business of adding value to your own company? And this is the previous graphic we have for the IT vending machine, rather. So I think we spoke about that plenty this morning. This is a mock-up we did for a company that I don't think we have the permission to name them anymore, but they had a bunch of different applications that, in this case, it was scientists that they can deploy. It's been going on for quite a while, by the way, as I was talking about companies that are leading on the innovation change. It's just that now we're getting permission to talk about it publicly. And number 4, thou shalt covet many clouds. We've been talking about that quite a bit, and I like what one of our persons in marketing came up with, remote control there. Here's a useful way to think about this. When somebody writes a computer program, they don't write it in such a way that it's only going to work on one motherboard and one CPU, and that's it. There's an abstraction layer there. Your computer program doesn't talk directly to the bus on the motherboard, or to the disk controller, or to the network interface card. So think of it in the same idea of an abstraction layer that makes it portable of your application and the way that it accesses the cloud resources. Is this idea that even if today, wherever you're deploying your application seems to work perfectly well in that provider, what if 5 years from now you're big enough that it makes sense to and economically feasible to deploy a private cloud because there's some cost advantages, or unbeknownst to you, your product or your service takes off in a different part of the world? And you heard the person from Ubisoft that said latency is the only thing we care about. So in a situation like that, you need to put those servers closer to the consumers of that software as a service so that it doesn't travel that far over the network. Do you want to build it in a way that makes it possible for you to move it later on? Or do you want to start by painting yourself into a corner and then having some major problems that you need to fix later on? So it's this idea of being able to preserve choice. And by the way, when we say cloud, and perhaps we haven't communicated that clearly enough anymore, now we really mean public and private cloud. I mean, from the way that we discuss it, we really make API calls to launch servers and to manage things. So whether it's in a provider that's charging somebody a particular rate per hour, or it's in your own data center, from the point of view of a cloud management platform, that's the same. So it's this idea of having the flexibility to move it to multiple places. And you go, well, I mean, how much of that am I really going to do? You saw this map also earlier today. Look at how much the world is changing. A number of providers, and we've officially announced all of these now, using different technologies, and some of these are exhibiting over there. Eucalyptus, CloudStack is cloud.com, now part of Citrix. OpenStack, there was a question about this today. Look at all the places around the world that they have data centers. And we're just barely getting started. Think of how much more this is going to proliferate. And now looking at, do I want to be able to take advantage of this kind of flexibility, the kind of pricing changes that are probably going to emerge as we continue to see the industry evolve. Again, as I was saying earlier, we're looking at a tectonic shift in the way that companies buy and consume IT resources. This is barely the first inning of the set of changes. There's an interesting thing here that we foresee a few years ago, and this is an analogy I'm borrowing once again from our CTO, Thorsten von Eichen. When Linux came out, there was this idea that the best version of Linux would emerge and everybody would standardize because it would address the needs that everybody wanted. Turned out no such thing happened. Some of the vendors optimized for better security, others for embedded systems or for faster operating systems, perhaps for high performance computing. Others had a different business model where they focused on selling to the enterprise. There's no one perfect Linux. There's different niches and verticals with companies with different technological and business strategies. We foresee that happening in the world of infrastructure as a service clouds as well. Not all clouds are created equal. They will differentiate themselves with different features or capabilities, pricing, geographical availability, as I've been talking about. And really, the point I want to make is, you really want to look at keeping your options open, like she does. Next commandment. I got that from Failblog, by the way, so I can't claim that. I found that for myself. Thou shalt architect for scalability and fault tolerance. Gets a little bit geekier here, so I want to talk about the benefits and the advantages instead of getting very deep into the bits and bytes of exactly how you design things. I said a couple of times already, I used to work in a data center. When somebody said, we need geographical diversity, boy, we just saw dollar signs back then, because you were going to spend at least twice the money, if not that much more. You need a data center in the East Coast and the West Coast, so get as much data center space in both places, buy all that equipment, come up with software and an IT strategy to be able to synchronize databases across the two different locations, so on and so forth. With cloud computing and with automation, that we provide from RightScale, I wouldn't say we made it trivial, but I mean, we've taken something like 95% of the work, and 90% of the work of being able to have your main environment, scales based on load, all the kind of things I've been discussing, and setting up, perhaps even in the same provider, a second site. And because you pay for the machines only when you're running them, these are grayed out so that you can say, well, these are on standby. I have the configuration and the definitions of those machines living over there, but I'm not paying for anything unless I really need to run them. I'm just moving my data all the time so that it's already living there in case I need to fire that up. You want to be in multiple places. What was that phrase somebody used to say when the Amazon apocalypse happened? You want to get caught in the apocalypse, or you want to stay ahead of the change? So, having, and I think one of the presenters also said they only went down 15 minutes, and because we were really designing things like this that were foreseeing potentially a particular geographical data center having a problem, having an outage, being able to prevent a serious impact to the business and to the perception of the performance that other people could see. So without getting into all the details, same provider, different data centers in different geographical locations, what does that look like? And now we've really extended it farther out, and my apologies because this is a fairly busy slide with lots and lots of stuff going on, but the ability to not rely on a single provider. You can have some things running in one provider, and then you can have your standby environment running in a separate one. It would be a pretty massive kind of network and data center outage if it's taking out multiple companies. At that point, there's probably some bigger things to worry about, I would guess, especially if you do this, different states far away from each other. My main point here, the ideas of how you do this are not new. What's really new is the amount of effort and cost and the time it takes to be able to put these things together now, and that you can drive that with the benefits of cloud computing servers and cloud management. And also having the visibility into what's going on. Now that you have companies running dozens and hundreds of servers, this we call a heat map. This is 100 servers, and the red numbers there is when the CPU load goes above a particular threshold. So it's really hard to look at 100 different charts and being able to kind of get a sense of what's going on. So we've come up with some tools to be able to have visibility when something's happening across many different machines, or looking at all the graphs stacked when you want to be able to see, well, probably something was happening over there. So having visibility into environments like that. So I've been making this case over and over of, okay, so what business are you in? Is your company going to build a cloud management system for itself, for the cloud resource pools that are out there now, or we already have the ark? You don't have to go out and chop down the trees and get the planks built and all that. So my friend Adrian Cockcroft, I don't think he's here, but I saw a tweet from him from the conference earlier today. I think he was retweeting something. Great quote. And Netflix is fairly famous for really making maximum or taking maximum advantage of Amazon in this case, and now I believe moving beyond. We want to use clouds, not build them. I just kind of move it out a little bit more, like I did with the point of demarcation when I was talking about cloud computing. You want to use clouds, not build them. You also don't want to build a cloud management system. You want to use that from somebody that all they do is have dozens of engineers creating that. Similar explanation of the value proposition. You want to spend your company's time and resources on the things that differentiate your company from the competition, not on the same things that every single company needs to do. What business are you in? Where do you want to spend your time?